So, as I said, work day, but I want to just do about like 10 minutes of stuff I want to tell you. So if you wouldn't mind just being with me for 10, so like closing up the laptops just for, I just want to clarify something. And it came from a comment from Daniel that via email. You made the comment that I totally get I get the total differential stuff and that. And so I thought, did everybody? Because I feel like my explanation wasn't that great. And I just want to take 10 minutes to explain what that total differential is. For some of you who will never have Calc 3. Let's just take, so really quick, and then you can work and we'll crank out shit and get it going. And yeah, oh, and also don't forget to give me your Euler's method, please, my friends. And I kept thinking, wasn't there something else I like vaguely threatened in my email?
Yes.
Yes. So let me put that here so that I don't forget. It's just another little assignment. Alrighty, so really quick on the total differential. It is truly a small assignment. It is a handwritten one, so it's, you don't have to fight webwork. So let's say I've got this function of two variables, z of z equals f of x, y. I can think of this as a surface. As I mentioned before, I've got an x and a y input, and I've got the z output. So let's look at a specific example. If I had z equals x squared minus y squared. Now that's a really cool shape. That's actually a hyperbolic paraboloid if you took Calc 3. And God, maybe they don't even teach that stuff anymore, which would be a shame. But it's something that kind of looks like this. It's actually easier to draw the hyperboloid first than to draw it on axes. So it's kind of, so it goes like this, and then here is the z-axis, and then here is the y-axis, and then the x-axis is actually right inside there. So that's not bad. That was pretty good. I like that. So one of my favorite things in math was drawing stuff. So it's a saddle. It looks like a saddle, right? Like you could sit on there and like little horsey head out this way, horsey butt out that way, legs over the side. So what if I was interested in estimating the change on this surface? So let's say I was at the point x equals 1, y equals 2. And I wanted to estimate the change in output if the x changed by a little bit and the y also changed by just a little bit, so maybe by that much. So right now, we could do it exactly, right? We don't need to do any approximations because what I would do is just say at the point 1, 2, z, the output, equals f of 1, 2, and that's equal to negative 3. Does that make sense? I'm just plugging it in there, right? I got 1 minus 4. Yeah, cool. At 1.1, actually let's do 1.01. Change this. Let's make it a little bit of a smaller thing. I think this will actually look just be more impressive if we do that. At 1.01, comma 2 was 1.998. 998? Not that many nines like that. So I'm taking this 2 minus this bit, and here I'm taking this x plus this bit, and getting this new point. Z equals, hey, could someone with a calculator help me out, please? Because I can't do that in my head. This would be f of 1.01, 1.98, and so that would be 1.01 squared minus 1.98 squared. Would love to know the true value of that. Approximating it will be easy. We can do that in our heads after we look at the total differential.
It says negative 2.9003.
Negative, sorry, say it one more time.
2.9003.
Ooh, that's nice. Awesome. So, the change was, Keitra, would you mind? Oh, we could probably do it in our heads. I'm just like, what's the difference between those two? And it looks like it went up. So the change in z is 0.0997. Yeah. Okay, cool. So this is the true change in the function as the point 1, 2 moves just a hair, right? So just a little bit this way and a little bit back, like that. And so what we're seeing is what is the true, like here is the -3, and then we moved and it went up on the surface just a little bit. But we can estimate that with the true differential, or excuse me, the total differential. So here, the total differential, dz, which we call df the other day, is the partial of this with respect to x. So that's 2x times dx, plus the partial of this with respect to y, which is -2y, dy. So I can use this to estimate, this is approximately the true change in z when delta x and delta y, or delta dx and dy are small. So let's just do that, and then I'll be done. But I just wanted to show you how lovely the total differential is and what you might actually use it for in a real life situation. So here, our dz is going to be 2 times our x coordinate, which is 1, times dx. And we're going to say dx is the change in x, so 0.01. And then I have plus -2 times y, so that's -4, because y is 2 somewhere there. And then times the delta y, which is -0.02. We can do this all in our head. This is nice. These are lovely little numbers here. So this is going to be 0.02 plus 0.08. And so we get an estimated change of 0.1. That's actually pretty freaking good. Hella good. Yeah, I'm impressed. The one I worked at home to like talk about did not turn out that good, but check out how that just is such a quick way to get that. And if these two were smaller in magnitude, this would be even better. So that's all I wanted to say about the total differential. Thanks for listening. Now I've got something else for you before you start working. Yes, thank you for that, Nathan. They're strangely loud. So this is a homework set that I would like you to turn in and start a class next Wednesday.
Handwritten.
Oh, it's all handwritten. Yes, I haven't done a handwritten thing in a long time. So back when I was a grad student, I used to get really crazy with this. I probably drank too much beer while I was doing this kind of stuff. So put all sorts of drawings on it and stuff, or other things. So welcome. And I gave you one, right, Anthony? Yeah, beautiful. Okay, cool. So let's just take a look at this real quick. So 6 problems. You figure out how to solve them. So I don't tell you if they're separable, and there's only 2 things they can be. They're either separable or they're exact. And if they're neither of those, you don't have to solve it. Does that sound good? Yeah. So you're like hoping, right? Like you just pray that it's neither, but you got to be sure of that. This will also let's see, what is the details? Please write this up on separate paper. Have a clean exposition. Include the problem details for each problem. So please just don't put 1 and then start like blah 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 blah. Put 1 and then tell me what the hell the problem is. Okay. 1 y equals blah. Just copy this. Just copy this down. And then start a class Wednesday. Does this sound okay? We can talk about it on Monday. So real quick, like just point, I don't have office hours on Tuesdays and I like it that way. So let's talk on Monday. Okay, cool. I'll work with you any other time, but Tuesday is the day I don't have office hours. That's my sanity day. Getting shit done. Alrighty, web work away. If you're already done with the web work, I guess you could work on that, or you can do whatever you want. Wouldn't hurt to work on that, right? Your brain's primed for Diffie Q this time of day. So, does anyone have, let's see, Daniel, why don't we consult? Oh, geez.
Sure.
You missed all of the description about this, but it's not too hard to understand. I think you got it. I'll stop by and clue you in on it.
Okay.
We need to talk. Let me grab my tea. That's not like a quiz or anything, just so you know, that's not a quiz. This is so there's no panic attacks.
I guess I'm confused. How did this equation were given into the form? Into a form.
So which equation are we looking at?
Trying to get it.
But I'd like any of these?
I was looking at this.
Oh, that one. Oh, gosh. Is there a place I could write that we could just call a scratch page? Beautiful sound effects and everything. Alright, so what do we got? Oh, here it is. There it is, beautiful. How convenient. So first thing is, of course, to change this to be like, yeah, exactly. Excuse me. So notice when I do that, let's just do it right here. To clear that out, I'm going to multiply through my dx, right? So this is going to get a dx as well as this. So those two pieces. So I would get a minus 10 x plus 6. And then all of that.
And you can just factor it in. Okay.
Yeah, I would clump it together and pull the dx
I
out.
was missing all this. I'm missing it.
Yeah, definitely. So dy. Now I'm ready to rock.
Yeah. Okay.
Yeah.
That probably solved a lot of issues.
I think so, yeah. So let me know if there's more problems. You're so welcome. A pleasure. Oh, wow, you're right, that is that fiery red. That is intense. That is really neat. I hope me walking around saying stuff doesn't bother anybody. I don't think it bothers you, but last time I taught DiffEQ, I had this student who probably hated me more than any other student ever has in my entire life. She didn't like me walking around. It just made her anxious. She didn't like anything about what I did. She didn't like me. Can't like me. Did you want to talk about something? Or are you just that you sorry? I'm just like this is like an auction and I'm looking for clues that people want help.
I mean, maybe.
You don't have to be coy.
I guess it's like, we have this, I just like, you mean like help with like the problem.
Well, yeah. Is there something you've tried? You're not quite sure what's going wrong. Okay. I'll come back to that. That's okay. Cool. Yeah.
So I think again, formula one,
Cool.
but didn't find it, skip there, yeah, I believe, on the derivative with respect to y, or dx, and then dx.
Correct.
Okay, so make sure.
Yeah. That's
Before I
good.
start doing
Yes.
that one.
Yeah. You do take notes, right? You take notes?
Yeah.
I mean, it's cool. You don't have to show me,
I
but.
just think like a rocket book, and I like scan it, and I have my.
Okay, cool. All right, good. Just so like, yeah. I was gonna say, you might want to if you're not.
Yeah.
So, yeah.
I just subplug it there, so I was like, minus 4 flipping through.
Outstanding. Ah, here we go. Okay. This one's got a lot of stuff. Okay, so it was like the only thing you needed to do was multiply through by dt, right? Yeah, that's cool. That's cool. So then it was exact. Yep. Cool. So then, oh, okay. So you're starting here. That's great.
It's on 6.
I'm not.
As long as you
I'm
just
not
make
there.
sure you do the other variable.
Yeah.
Absolutely.
Do you
Absolutely.
have the same?
Okay, that's beautiful.
Yeah, I think they're.
That's great.
Why is it was multiplied
Oh.
by that?
And I
Oh.
took the.
Gotcha.
So you multiply by the denominator.
But
You
you
try that.
I don't think it's right, so,
I
you have a
s-
pencil?
Yeah,
I
I
suck.
Separated.
Yeah, I'm always, like, when people do them, when you have like a derivative of a variable in the denominator, I think it's better to just rewrite it as a power, a negative power for.
Yeah, sometimes I do that, but I.
Yeah,
think
that's-
it's set into your-
They've got you here. So, let's take a look, so this guy here, you see?
Yeah,
Yeah,
so basically
so-
when we can like erase some of this.
Oh, that's okay. I don't think it's just a little change here. So I'm gonna rewrite it as 1/4 t squared y to the negative 4.
Yeah.
And then when I integrate, that goes to, oh wait, you're differentiating. Oh, actually, you did okay, I'm sorry.
Oh.
I thought this was the integration step. No, this is great, you actually did good, that's impressive. That's really impressive. You got that. Yeah, great work on it, yeah, that's great. Okay, so then you took
You
that
stuck.
and you set that, you decided then that C prime had to be
I
0.
kind of like did that over here, so I was like, oh, this is equal to n, and then it's possible this is where, but I was like, so this is like negative, and then I kind of like split.
So I wouldn't do, I think this is gonna cause you a little bit of pain. You can just work straight from here because this thing here must be this. So, and that, so that allows me to see that C prime y has to be 3y squared.
Okay.
And then that's cake, right? It's a lot less work than what you're going through here. You see what I mean? So C prime y must be 3y squared. And then C is y cubed plus, yeah, life is so much easier that way.
Okay.
Oh,
I guess like,
you
what would be like C y
I was like looking at that over
squared
there.
over one of those two?
No, just by itself, cause that's, see, he's off to the side there. So it's negative t squared over y to the fifth plus this other thing, and it's that other thing that we're always trying to find in this process. And it'll just be a thing you add on that's not really related to anything, but you'll see it in the other part. So if you start with this one part, and then you integrate up, and then you differentiate down, you should see all of that in the other term. You'll see all the stuff that's not the C, yeah, that should be the C prime. Does that kind of make sense? I thought it was pretty vague in here, but.
Well, it's just, it's like if this is equal, so like if this is supposed to be equal to this,
Yes.
So you're always choosing MCX.
cause
Oh, that looks better than mine.
I guess, cause like this is all in the numerator, that's why I was.
Oh, wait, was it? Oh, I didn't see
Yeah,
that.
I
Oh,
kind of wrote it over.
oh gosh,
That's
oh,
right.
gosh, oh, that changed. Oh, that actually changed some stuff then. Because that means
Yeah.
that this, what I would do is rewrite this as 3y to the negative third.
This should be the x.
Yeah.
minus.
Okay, and you added in the y.
So this is C prime.
And then
Yeah,
integrate.
that's kind of what I
Got it.
like.
Oh, okay, okay. Oh, I see. Okay. This seems to be going well though.
This y stays the same, x goes up.
Wait, what is this?
I did something weird.
X cubed.
This one?
And then, I'm pretty sure.
For here?
Oh, never mind.
Let's work it from where.
Yeah, my writing is not very good here.
You're gonna get now,
I'm
trying to
C prime of
So,
y
yeah.
has to be this 3y.
This is my problem.
So I'm just gonna write that down.
The first what?
And then
I'm trying to.
take the
And you integrate to
so
C.
then I
Like,
get
did you get like the assumed dx equals something?
The negative
Wait,
six.
what's up with that?
this.
Yeah, so that's.
Yes,
what
yeah.
you've got.
Okay,
Mhm.
I'm just trying to figure that out, basically.
Okay. Do you want me to
Okay,
try
I
it?
see, yeah, that's all looking,
That's what it
it's
was.
all looking good.
Can you like back that out?
So our F.
No,
I'm
I just,
gonna write it out without
so I
looking, so you
took
have
this
this
part
little,
as
like, you get
dm,
independent.
and this part is dn.
Accounts of what's
and if you-
happening.
and if you take
So
the-
it's equal to t squared over 4y to the fourth.
None of these are separable.
Minus.
Got it. See, I thought they were separate.
That explains the struggle.
Thanks.
And then, the other plus C as well.
Oh, yeah, and then the plus, yeah. So I usually put that in here, so we're gonna set that equal to C. And like, what's cool about that is whatever this turns out to be, that's your C. Unless you have to sub, does this one make you sub, oh, and then you gotta. I am gonna
M,
go
I
talk
took this
about
part,
one on the board,
and
Okay.
because
N, I just
this
did
is
this
one
part.
I wanted to talk about.
Okay.
Is it okay if I just bump this really quick?
Yeah.
Yeah.
Oh, like, oh, yeah.
Yeah, I'll be right back with you.
Yeah, yeah,
I'll be
yeah.
right back with you.
Yeah,
What problem is this?
Number 4.
Hey, can we talk about number 4? Please? Because there's some stuff going on there. And I'm gonna pick it up from the point where you've actually, it is exact, you've got it all worked out, and you come up with your answer. And I'm gonna go with Thomas's answer, because I know that he did work this on his own, so his answer looked like this. Yours will be similar. And then there's like a, we'll clean that all up. That's like his notation and then my notation combined into a strange child. So this is actually t squared over 4y to the 4th. Just to get everything consistent. So then, that would be great if they said, just give me your answer in implicit form, but they don't. They say y equals, and we had a good conversation about this earlier, Lavina and I, because this is something, and this is something that I wanted to talk about. So, what I would first, there's actually so many ways to approach this, but what I want to do is, since I'm solving for y, I want to get y up on top first. So I'm going to multiply through by y to the 4th. So I'm going to get t squared over 4y to the 4th, and I'm writing it like that for a very particular reason. And then this is 3/2 y squared, and then the c, I don't know what that c is yet, so I'm just going to bring it over here, and since it's not assigned yet, I can just move it over as plus c. Right, you might be thinking, well, it should be minus c. You'd be right, but this is also right at this stage. That's one of the good things about all of this. And this should not be this. Wait, that should be this.
The y 4.
Oh, right, yes. Yes, so I multiply, yeah, y to the 4th, right, like that, yeah. Oh, this turned out a little, is this the one we worked on, Lavina?
Yeah.
Okay, because I'm feeling like, this seems like not as brutal as the one we were working on. I feel like we had a constant with, did you actually enter that and get the right answer with what we talked about?
I'm putting it in, but there's way too many brackets.
I think that, yes, Hans, yeah.
Well, I'm just wondering what why the y to the 4th didn't cancel.
It should, that's the problem. That's the problem, okay,
Yeah.
that was just bad algebra, good call. Man, with all of us here, we'll be able to do math. This is great. Thank you, Hans, that's absolutely right. Because I was thinking this should have just turned into a quadratic, and it is. So this is a quadratic in y squared. And what I mean by that is anything that looks like this rhythm, you've got some quantity, and it doesn't matter what that quantity is. It could be some nasty expression. It could be sine, it could be, make up whatever you want, put it in there, you have a quadratic in that thing. So we know how to solve this. By the quadratic formula. And that's what we're going to do here, but in our box we have y squared. So this is a trick that occurs often in diffie-Q. In fact, I just ran into Dr. Seibert on the way back, and he said, he was asking about Lavina's problem. He said, did you give him that one? I was like, yeah, I did. You betcha. So, we could solve for c at this point using our initial conditions, but let's hold off. Because if we hold off till the end, and this maybe would have been something good for us to do, Lavina, like hold off until the end, because then c can absorb all sorts of stuff, and we don't have to carry it. So here, I'm going to get y squared equals the opposite of b, so 3/2 plus or minus, right? Because this is my c, this is my b, and this is my a. There's a little problem with that c, whatever. So square root of b squared minus 4 times a times c, so that's going to be 4 times this dude, which is t squared. times C, which is just C, and that's really lovely, all over 2A, which is just 2C. Yes?
Shouldn't it be negative c y to the fourth? On the third line.
No, so it could be, but then we haven't assigned C yet, so I just let it absorb the minus. Isn't that nice?
Yeah.
Yeah, absolutely. And I could have even multiplied through here by 4. That would have been a sweet move. So if I'd multiplied through here by 4, this thing would have looked like this. And I'd get an extra 2 there. And then suck that into the C. That would have been better too. So, whatever. We're already going down this road. We'll just keep riding with it. Any other questions or comments up to this point? Alrighty, so then y is take another square root, and remember, when you're the one doing the square rooting, you don't know where it came from, which branch of the square root. So, got this. Regretting the fractions, but you know, dealing with the choices I've made in life. And here we go. So, Thomas, what was your initial condition?
It was y of 1 equals 3.
So y of 1 equals 3. So when x equals 1, y equals 3. So now let's look at this. Notice that the y is positive. That tells me I pick the positive branch. If that had been negative 3, I would have gone with the negative branch. But we're going with the positive branch. So that's one choice made. We got another choice to make in here. So let's plug in those numbers. We're going to get 3 equals square root, 3/2 plus or minus root, 9/4, I guess this is t, not x, minus c, all over 2c. Okay, so now how do I make the next choice? I need this thing underneath here to be a positive number, because I'm taking the square root of it, and we're not doing complex stuff. Hopefully I'll see some of you in complex analysis this fall, but that ain't this class. Eventually we're gonna do some complex stuff, but not with this. So that means I'm going to make the choice here, the plus or the minus, that makes this quantity a net positive underneath there. Hopefully there's not 2 of them. I hope to God there's not 2. Let's actually finish. Let's just do a little more work. So Thomas, you still have to like kind of think this all through. I'm sorry to take all the joy from you for this. So this is 3 equals square root of 3/2. Oh wait, what am I doing? Oh, that's already it.
That should be the answer.
Yeah, but now I gotta find C, don't I? Boy, I wish I'd found C earlier. What a chump. So maybe finding C up front would have been okay, but oh shit, all right, let's do it. Let's find the damn C. Again, you make choices in life, and you live with them. So 3 squared equals this. So now I'm literally going backwards in time. My God. 2c. So this is going to be 18c equals 3/2 plus or minus square root of 9/4 minus c. Get everything except the square root on one side. Oh shit. Oh man. Oh God. Oh. Yeah, what?
Wouldn't it be easier if we just use that equation?
This
up
one here?
No, the t squared minus 6y squared.
Yeah. Yeah, that would have been a better place to find C. Yeah, I agree. I wish I had done that, but I didn't. And I don't know that that C is necessarily consistent with the work that I've done. So you got 2 options. Find the C up there, smarter move, or do this bullshit. Don't do this bullshit. But like, can you see what else would happen? So that's why I'm doing this, Lavina, because I have to like undo all the dumb decisions I've made. So yeah, if we just do it up here, what would we get? It would be so pretty. 1 minus 6 times 9 this is, you had something almost like this, didn't you? You had like a 53, I thought, in there or something?
Yeah, 53 over 320.
Oh my God, look at that. So yeah, 53 81sts. Well, that's how you do it. So then carry that along. I would just like keep that in my answer, and then when you get down to here, you can make the decision on what C should be. You can, yeah. Here, notice that since C is a negative number, or no, it's a positive number. This would have to be the plus branch here. So, yeah. That's number whatever that was. 4. Thanks.
Number 4 in the homework.
Yes. Yes. Yeah, I wish 4 was the answer. That'd be cool. All right. Yes.
Hello.
Hello. So this is real quick. This do start a class. Now you got to pick the method, and not all of them can be solved. So the ones that there's maybe one or more on there that's not separable and it's not exact. So you just say can't do it because. Okay. Cool. Yes, your question.
I don't even have a question. I'm just confused.
Hopefully it's about math because I
Oh,
can't
it
help
is
with
about-
anything else.
It is about that.
Okay.
I'm just confused on algorithm and I think the notation is missing. I don't know why. I just don't understand this. Cause you have to, I don't know, I just don't know where to start.
You know, we're saying, okay, so where are we starting? So let's make sense of these so you can look back at them.
That's where I started.
Okay, cool. So there was a point where it's like, here, how to solve an exact DE. Step 0, make sure it's exact. So what is M and where does this M and N come from? What does that refer to? Well, it would be, so the M is the part, so you gotta do some algebra before you can even decide that. So you're gonna find a bunch of stuff that has a dx on it and a bunch of stuff that has a dy on it. This is the M, so anything that gets clumped with this, like this won't, this is gonna have a dy on it, but these two pieces will get a dx. So this will be M, and then this will be N, right here. So that's step 1. Step 2, and we're actually assuming that this is the partial of f with respect to x, so this equals the m. And then I integrate with respect to x. I get f equals the antiderivative of that thing. And then I take that and I tack on a plus c of y, because remember, does that ring some bells? Yeah. And then I differentiate that. And the partial of that with respect to y is going to be derivative of this thing with respect to y, but more importantly, this thing's derivative. So here I'm going to get partial with respect to y of this thing that I integrated. There might be y's in here, right? There's definitely going to be y's in here. But then this becomes c prime of y. So then I compare this. This must equal x, or n. So this must equal n. So once I do that, then I know, I compare this answer to the n that I have over here, and here it's going to be just this 2. And see what the difference is. Any extra terms that don't appear here, I'm going to let those be c prime of y. And then I know c prime of y, so identify c prime of y, and then integrate c prime of y, integrate with respect to y, integrate to c of y, and then I tack that on, then I'm done. Then the answer is just going to be this, equals a constant. Does that kind of make some sense? So try it. Now come check on it. Yes, Hans.
Okay, I have 2 questions. First,
Oh,
it's
good.
just about this. It says my answers,
Well, it doesn't seem to like your answers at all, does it?
but it says they're correct.
Well, then that's weird.
That your answer is correct, but your score did not change.
Well, you shouldn't be, can you log back in?
It was
Is
the
that number
one
3?
attempt one.
Is it being,
Yeah,
you
no.
only had one attempt
Yeah,
on
no,
it?
apparently it
It
says
was
at
like-
the top you can only have one attempt. From the bottom, you can submit your answers as much as you want, but it won't change your grade.
Yeah. It'll tell you got it right. It just won't say. you
Yeah.
got
Well,
it
that's
right.
bunk,
Oh,
but
yeah.
it will give you the credit?
No, I have
I have 2/3
0.6.
credit.
0.67.
Oh, well, that's, I don't like that. Let me go fix that.
If I can, I might have to, hopefully I don't have to get deep in the webwork code. So that, okay, that was question, that's like, I'll fix that shit.
Sure. And then the second question, I know that these are exempt because I differentiated and this is n, this is
Yes,
n.
that is exact, yes,
Um,
absolutely.
So am I doing it right from this point on? I'm assuming that df, dy, because I was given dy but no dx.
Which you were. You multiply through by the dx. This is a big part of all of this. So, when you have not a differential but a derivative, multiply through by the denominator. That's gonna be essential for doing all this stuff. Does that make sense?
Yeah.
So this will then be the m dx.
Okay.
Yes, yes.
So
I don't know how I got
those are the answers.
Uh-huh, yeah. There you go, yeah.
Okay, so
You're not doing
then
it.
should I start with df dx? So this should be x and this should be this right here?
Yes, you can start on either side, but since you're just learning, so you can start with assuming the partial of f with respect to y is this piece, or you can start that the partial with respect to x is this piece.
As long as I integrate one side and then
Then what?
do the derivative of the other side afterwards. Once I get there, I guess I'll compare that with the and they should be equal. Yes? No?
They might not be equal, and the difference will be, so you're gonna integrate. I think I need to work through, let me work through an example.
I must have
Okay.
been in other worlds then.
So if anyone is
Okay.
not quite sure on how this process works, I'm gonna work an example.
C prime equation is set equal to n, and then solve and then integrate,
Okay.
and then plug. Now, I can just do it, that'd be nice.
Okay, so you said C prime 1 equal to whatever you found, and you differentiate again.
So you found that equation,
Yeah.
set it equal to n.
I just gotta find a good one to do.
Yeah.
Okay.
And then you. Yeah.
Okay, so, I think this is a good one to do. I hope I didn't do this one, I guess it doesn't really matter.
Oh, it's because I had done that. So if that's n,
Oh, I'm gonna write it out this way, just for now.
then that's what we get.
So before I can even begin on this one, what do I need to do? Can somebody tell me? Yep, that'll come second. What, I need to make an adjustment first. What adjustment do I need to make?
That's a constant, that's gonna be 0.
Or at least what I need to realize before I pick what M and N are. Anthony?
Is it that negative? It's plus negative.
Yeah, so make sure that this is what you have. You need, the method doesn't work if there's not a plus in here. So be really careful with that. So step one is change that to a plus and distribute like so. Then step one is check that it's exact. And I'm just, yes, it is, because I checked it. So yes, check the partial of m with respect to y. This is m. This is n is equal to partial of n with respect to x, and here we are good. So that's step 0. Step 1 is set first partial of f with respect to x equal to m. So here, that's going to be first partial of f with respect to x equals 2x cubed minus xy squared minus 2y plus 3. Integrate to get f. Integrate with respect to x. You can do this the other way. You could start with partial of f with respect to y equals n, and then just do y instead of x here, and x instead of y when we get to the end. Whoa, shit. Integrate with respect to x. So here I'm going to get f equals x cubed minus 1/2 x squared y squared minus 2yx plus 3x plus you have to tack on this constant that could be a pure y thing. Yeah, and I'm wishing, I'm going to change this. I'm going to change this problem a little bit because I want it to be cool. And I don't think it's going to be as cool as I want yet. Wait, whoa, is this thing even exact? No, it's not. Okay, let's take the partial of this with respect to y. Shit, I gotta check and make sure this thing is exact. I'm just spouting all that stuff off. Partial of m with respect to y is negative 2xy minus 2. Partial of that, oh, we're okay. Partial of m with respect to x is negative 2xy minus 2. Okay, cool. All right, we're exact. I just got scared. So I guess I'll just keep doing it. So this is all looking good because you all are good at catching stuff. Did I
Is
something else?
that integration right the first time?
No. So that's actually false. So when I integrate that with respect to x, that should be 1/2 x to the 4th. Thank you, Daniel. That's a good call. Does everything else look cool? With respect to x, yep. With respect to x, those are easy there. Those last two. Good call. Thank you. So now I'm going to differentiate that with respect to y. And that's going to get me first partial of f with respect to y is equal to dead. This is going to become negative x squared y. This is going to become negative 2x. This is going to go to 0, and this is going to become plus c prime of y. And I do wish I had tacked something on, so let's do it. Change the problem just a little, and add on a pure y thing here. So let's add on sine of y. That'll make it more interesting. Then you can actually see what happens when they don't match up. So this must equal the end. And here that n is equal to negative x squared y minus 2x plus sine of y. So I compare now. And this is what I was trying to say, Olivia, but it was hard to say without an example. But I use this now to find c prime of y. So that all cancels, so c prime of y must be sine of y. And so then I integrate, and that means c of y is negative cosine of y. Then my final answer, now you're done, the hard part's over. So your final answer, good Lord, is going to be whatever the f you constructed was equals c. So here it's going to be 1/2 x to the 4th. Scared there for a second, that's okay. 1/2 x squared y squared minus 2yx plus 3x minus cosine of y equals c. That's the process. Does that help, Hans?
Mm-hmm. I still have questions.
Oh, cool, that's okay. I'm not trying to say you don't.
Oh, sorry, Nathan.
So, yes, I'm supposed to take the integral of this because I chose to start here.
So you're starting there? Yes. So let's do that.
So,
Bless you.
taking the integral, honestly, I think multivariable integrals.
This is great. You did good.
Okay, so
That's it.
that's a 3.
Uh-huh.
Um,
And that's plus, now plus c of x.
yes.
Right? Does that make sense why
Yeah.
I would do that? Okay, there you
The
go.
whole term
Cool.
is equal to n, and that's how you solve for c prime.
So no, that equals f. This
Right.
is f.
Okay.
Yeah.
So then we take the derivative of f with respect to
X. Now, yes.
I got some unknown variable equal to negative x.
and then we have the c prime over here.
Cool. You're like cool.
Is this right?
That is bad of a variable.
You're just making stuff up. It's called later.
Yes. Yes, it is. Yes.
Okay.
And so what does c prime have to be then?
Well, if n is supposed to, okay, well, let's just find n. this is n. So 3xy squared.
That's not n. Oh, wait, sorry, no, you don't want n, you want m because you're doing the opposite of what I did. You decided to be a rebel,
Okay.
and free can come in the back door.
M equals this.
Yes.
Oh, that makes easy.
Yeah, it actually like looks the same, right? Like, if they don't look anything the same, something's gone wrong.
That's good
Yeah.
to know. Okay.
The C.
Then this is
CO.
simple. I can do this.
Okay, you good?
Because now
Yes, thank
Okay,
you.
You're awesome. You're welcome. You're awesome and you're welcome.
Is it just the one we sent today?
Yes.
Really?
Yeah, I thought the Euler method was the
Oh, the oil.
I
Oh.
was totally confused about that.
Oh gosh. Great. I'm glad that helped. Oh, you're welcome. I'm glad to help. Anything I can do? I'll be over there. I'll be right over.
Oh no! Okay, look, I still have to see kind of why, so now I can integrate, right?
No, not yet. I'm still trying to figure it out.
I'm asking this. Usually we use
Work together? Yeah, for sure. For sure. I don't really
I would actually
know how useful I'm gonna be though.
Because sometimes when you do this stuff, you can change the exactness.
I've gotten this far.
Exact, so what I would do, oh, yeah. Okay.
Oh, okay, yeah.
I will picture a whole crab.
Right. So it's 2y squared over y.
Then skin turned into.
Oh, that's probably just because our problems are different.
That I would do it like that.
Yeah.
But then you simplify it to be a lot.
And everything
I don't
goes
know where
to
to
your
That's gonna be
how to format this
if I
answer though.
multiply
Is the
through by
problem.
dt. Yeah, does that make sense? Yeah. And then I would
So,
simplify these things as much as possible. So this would be 3y to the negative third. I would use those negative exponents. This is just gonna be, does that make sense?
Yeah,
And
and
then
that's just t squared y to the third.
yeah, y to the negative third, t squared. Doesn't matter what order you do,
But
right?
straight.
Does x squared?
Well, not here because they're not, oh,
Or
yes.
does it stay
Yeah, there's no y
That's
subtracted,
just
so it's
Mhm.
like a y to the 0 on top, yeah, exactly. So like, negative exponents are the same as having so this is actually like 3 over y cubed,
This is my C.
right? You can kind of see that here, that you can cancel y squared out of the top and bottom. Does that make sense?
Yeah.
And then here, I would write this as 1 y to the negative 4t equals 0. And it just makes the calculus, because you can use the power rule. And otherwise,
So why?
Does it sound good?
Yeah.
So you're putting go 0 and down.
So M is the one up here.
When you
And that equals,
Isn't that what
yeah,
you
that's
do?
equal.
Okay,
Are you doing it?
This just, imagine that this is like another.
Right, okay, so this is df.
Yeah.
This is df dx. I brought it down here, and we're going to compare this to, whatever, we're supposed to compare this to M.
First get rid of the derivative.
And so,
Right,
that looks like C
that's what I'm trying
prime.
to find exactly.
Just
I know-
throw it
That's
down.
it. So I would
I know you're trying to do
y
this.
prime or
Mhm.
dy, d whatever.
Yeah.
Multiply through by this bottom. So this whole.
But this was the df dx, yeah. So, since this was what I got for df dx, we compare that to what I got for what M is in the problem. And the difference, since the y to
And
the
this isn't
thirds
that better?
cancel.
Yeah.
Are you good? The y to the thirds
Oh,
cancel.
yeah, you don't need to
And,
separate, because we're doing
all that
exact
leaves is
equation.
C
Check
prime
the exactness
and
first.
18,
Oh,
negative
okay,
18
and
x
then
minus
just,
2.
okay, gotcha.
And it's gonna be exact. And
I have
then
to figure
do
out
that
how to,
process
like,
there.
where's the y?
Yeah, after that, okay, I thought it was doing that.
Yeah? Sound good?
Yeah.
Okay.
So, yeah, I think, I don't know,
Makes it-
the very last
Question.
Dr. T, I have one more question.
Oh, you're gonna have to wait, you're
Okay.
gonna have to wait. I got a queue going, Hans, hold on.
Right here.
Oh,
So that would be C.
Okay,
Wow.
so now
And
this
that
is-
right constant
Which
from
one?
like.
I don't know.
Well, you don't know which problem you can find right.
Yeah, C of x.
See if X you said?
Because when you integrate
Oh,
it,
not exact. Oh.
I don't even know what you're
Like, the very final step.
Right
That
now,
sounds right.
right
This
now,
should be
I'm trying
a
to find
function,
connection
because
between
it's
my
not-
right now,
Oh,
it's
okay.
five,
Good
which
way
I
to
know
do
doing
it.
differential
Okay.
equations.
I got it.
But in my mind,
Oh, which one is that?
did you say?
You just
I'm
said
also
it.
thinking about variables.
Oh, okay, I thought we were looking at this,
Oh,
okay.
For yours, I think it should be.
Got it.
We were in class and she said,
Yeah,
This
that's
was
why
the
you
way
should
the
be
conversation
doing
went.
more, right, you know? I might be dumb,
A dive.
yeah.
Yeah.
and she was like, yeah,
Alright, so
We'll see.
I don't know how I did this, but this is how I did it. So they'll figure it out. I'm like,
It has to be capital,
Okay,
right?
this is so.
Yeah,
wow.
I think that X has to be smaller, but everything matters.
A physics teacher.
Y
Oh, I see. There it is.
Okay. Got it.
Have white cube here.
The moment either I get
Oh,
it
that
wrong,
X, that's it.
I don't
Okay,
know
got
what I'm
it.
doing, I give up and move on. Since there's only 6 questions, I
Just
can
like-
only give up so much.
Should be exact, yeah, I see
Oh,
what
I
you're
see.
saying. Cause
Yeah.
derivative of that with respect to Y is not one.
So,
Yeah.
Just plus 2 after C.
okay.
Which problem is this?
Did you put the parentheses?
Oh, I'm sorry, you did.
Okay.
X and then plus 2. I forgot about the division.
Plus,
And then raise the whole thing to 1.
I'm doing that one now.
Wait, I was like, how did I get number 5 right? Wait, are you number 5?
Yeah.
And then you want to put parentheses, you got
to the,
1/3.
No.
I think you
No.
might be right.
So C should just be a.
This is my answer.
That'll make people happy. That makes everybody happy.
Did I get this right?
Now, just out of curiosity, did anyone solve number 6 on the webwork? Okay.
I did, and it was
He was one of
disgusting.
mine.
How did, I gotta see how you solved it, cause we don't think it's
Like
exact.
This problem?
I erased it because I was.
oh, okay, so
This problem, Chris?
the integral,
Yeah.
you chose to
It's
do,
Not the one with all the green.
This was my answer.
I chose to do this,
Yeah.
that's why it's confusing.
Oh, okay, that makes
Okay,
sense.
same.
okay.
Yeah.
Oh, God.
I did it by
So you
hand,
just
and I
have to
put it
add-
into a computer, and I went to
So
bed.
See,
this
release
equals
So Labina was
y.
pointing out, I don't think that's exact, and even though it was in the
That
exact,
equals-
homework set, like I was looking under,
Oh.
problems that are
I've
exact.
been doing that one this
Oh,
entire
it's right
class
there.
period. And I've been
So this is F,
frustrated.
and then
Oh,
you-
that equals C, I'm sorry. I think the
How
whole
long
thing
was that?
equals C.
Oh,
It's been a
it has been a
while.
while.
Yeah.
The whole thing
Like I
equals C.
started, I tried starting now.
So
That's
I-
the confusing part.
I'm just confused about getting it into the format of the Y.
I'm just saying, I'm saying I did something nice for you.
I was just
Okay.
looking though, cause here's all the work.
Uh-huh.
and
Yeah.
Like, I've been following the same pattern.
Okay.
Yeah, we did it 2 different ways.
Let's do it on the board together, may I?
Yeah.
And we'll do this on the board, and everybody will be
I
happy.
think I understand.
Yes.
You will definitely stay.
No, I think I get it. I'm just gonna try the nuts problem and we'll see how it goes.
Mhm.
Thank you though.
No, I'm not.
So Labina might have saved you all a lot of pain.
Wait, for what?
So this is, number 6.
It's in the spring, right? Or is it in the fall? Yeah. I know, I'm so excited.
Wait, is this the number 6, Chris? Or wait, Kitra?
Mine is,
Cause, wait, where's it on this
oh no,
page?
that's after I
Where's it on the,
separated
can you show me, where's the original? Do you have it written down? Or just let me see?
Here, I
Yeah,
have,
this is
there
the
we go.
original.
Okay. So, number 6. Oh my God, that answer, Chris. Well, I'm gonna have to make cookies or something, I guess. Make it up to everybody. Okay, thanks. We're gonna take a look. Let's double check and make sure. So I multiply, and that's equals 0, is that correct?
yes.
Okay, beautiful. First thing I would do is break this apart, so we've got y over 1 minus x squared y squared dx plus x over 1 minus x squared y squared dy equal, and sometimes when you, if you multiply through and try to clear out fractions, that can, I believe, change the exactness. So that may or may not be the problem here, it's still looking pretty grim. So we got that, and then this is all dx stuff, so let's just, oh shit, so y, 1 minus x squared y squared, there's no way this is exact. But you never know.
I think it's, is it,
Yeah,
shouldn't
that'd
it be
be
plus
plus
X?
X.
Can I say like,
What's that? Wait a minute, hold on, somebody's
In the
correcting.
first parentheses,
Where?
plus X.
Yeah,
The-
so
Yes,
it'd be
thank
plus
you.
X.
Yep, got it. Is that what we were talking about?
Yeah.
Yeah, cool. So then let's just check our partials with respect to y. Huh. You know what? I don't know. I'm starting to wonder. This might be exact. So let's take a look. This is actually, let's write it in a form that looks like humanly. Oh, we can do the freaking quotient rule. Good old quotient rule. Who'd have thought that shit was useful? Okay, so I'm gonna take the derivative of this with respect to y. So I take the top first times the bottom left alone minus top left alone times the derivative of the bottom with respect to y, which is 2x squared y. Yeah, I know you will stop me if this is wrong. And then this is 1 minus x squared y squared squared. Let's simplify. So then that's gonna be 1 minus x squared y squared. So Katra, I don't know, Katra, you might not have wasted your time. That's actually 2 of these, so it's actually, this just turns into a plus. I don't know, what do you know? We'll see. I'm not sure.
I hope it's not exact.
What's that?
I hope it's not exact.
We can pray, we can hope, but let's find out. So the derivative of this with respect to x, do the freaking quotient rule. 1 times 1 minus x squared y squared minus top left alone times the derivative of the bottom with respect to x. I think it's exact. And I think that maybe what you did was did you clear out the fractions first?
Yeah.
That'll do it. I think that'll make it not exact.
Is there a reason that it does that?
But isn't that 2xy squared and then for the other one is 2x squared y?
This, like, wait.
So that block and the other block?
yeah,
Okay, hold on, so are you saying I haven't simplified completely?
Oh.
I think it's exact. Yeah, you did not waste the last hour, but let's talk about this one together, since you've been suffering with it. I'm glad we had this conversation. Oh, it is a fun one. Let's take a look together. So once I've got it separated, this is going to be partial with respect to x. Oh, okay, yeah, let's talk about this. That's some good calculus review. Yeah? So take this, going to integrate up with respect to x. And that's where the fun comes, isn't it? So we need to talk about this. Okay, good. So how do I do the antiderivative of this with respect to x? Oh, we're talking about something else. Okay, cool. So I can do partial fractions. So let's just see here. I mean, there's a couple ways to do this. So that term there, that's the real bugbear, right? I don't know if that's just D&D talk or what, but so then this is some constant over 1 minus xy plus some other constant over 1 plus xy, and I'm doing this with respect to x as my variable. Yeah, so y just acts like a constant. So partial fractions, so this is a constant on top. So then to do partial fractions, I multiply through by the denominator. And then the appropriate things will cancel. This is a difference 2 squares factorization. So this one cancels here, this one cancels here, and I'm left with the other. And then I pick values. So let x equal 1 over y. if I let x equal 1 over y, this piece dies, and I've got y equals a times 1 plus 1. Isn't that nice? So a equals 1/2 y. And then b is probably negative 1/2 y. But maybe not. Let's just see. So let's see. So then let x equal negative 1 over y to kill off this. And so then I get y equals dead. And then that becomes 2. Oh, so b, oh, that's lovely. So b is just 1/2 y as well. Cool. So this thing, this beast, actually, I'm going to rewrite it first. This is actually, before I go to my integration, this whole critter is going to be 1/2 y over 1 minus xy plus 1/2 y over 1 plus xy, and then I got plus x again. Now it's easy to integrate by, with respect to x. Well, easy in some ways. Let's actually pull that freaking 1/2 y out in front so it doesn't pester our minds. So to integrate, so now I'm going to integrate with respect to x. And this is going to become 1/2 y. And I'm going to be really curious what you did to get your answer, Chris, because it's looking very rightish as I go through this madness here. So
I didn't do partial fractions when you with the y over.
Really?
Yeah, I didn't do that. So
That's
that
okay.
must have been how I got my extreme answer.
it's not that extreme. I think it's pretty, actually. I do. So let's take this with respect to, integrate this with respect to x, and you get negative 1 over y natural log. So this is negative 1 over y, natural log absolute value of 1 minus xy. You can check me out on that. Derivative of this with respect to x is negative y, that cancels with that, gives you a 1, boom. And then I've got plus 1 over y log 1 minus xy. And then plus 1/2 x squared plus g of y, or c of y. Holy shit, let's simplify, because this isn't so bad. Then this is negative 1/2 log 1 minus that, and the y cancels there, plus 1/2 log 1 minus xy plus y. This shit's all on tape too. So, tape. Such a geezer. All right. Sometimes, and I'm just sitting here and just babble to myself and hope that something's happening in your minds, I guess. Okay, so now what do? Differentiate this with respect to y. Okay. So partial with respect to y is going to give me negative 1/2. Derivative of that with respect to y is negative x over the bottom. You know, God, hopefully there's some like way this shit, one of these should have been a plus. Yeah. So then this would be positive x. Really? What? Oh my fucking God. Oh jeez. Oh, that's amazing. Oh my God. No, it's not. Oh, I thought these two were like gonna dissipate, and
The answer isn't 0. I tried it. Don't worry.
yeah. And then okay. And then this goes to C. This goes dead. This goes to C prime of y. And that's supposed to be that thing by the dy. Oh wait, right? Yes, that's the thing by the dy. Oh, whoa! I think C prime is 0. Let's see here. So let's bring these two fractions together. So simplify first.
I can't type 0 wrong, can I?
No, well, How did you spell it? 1 half x, 1 minus, 1 plus xy. And then this is gonna become, why am I doing that? 1 half x out in front, 1, 1, boom, boom. And then this becomes 1 half x, that, plus that. Oh boy, look at that. That is working out great. Boy. See, this is what we live for.
What are those values?
Oh my
The
God.
1 minus xy and 1 plus xy?
Say that, I'm
What
sorry.
are those values in the brackets?
Those are 1 minus xy and 1 plus xy.
Okay, and what's,
And then-
but what's, are these
Here,
ones?
Those are ones,
Okay.
yes, sir, thank you, yeah. And that's a 1 half x out in front.
Okay.
And this is like why, this is when math is just so amazing. This is a 2 on top, and then this bottom is just 1 minus x squared, y squared. And so, look what I got, this is just x over 1 minus x squared, y squared, and I keep forgetting my freaking c prime, plus c prime of y. So, all that to just see that c prime of y is 0. And so our answer, here, I'll just give you the answer. And you can find your C and shit like that. The answer is gonna be, oh my God, where's F? Where's F? Here, okay, so the answer is gonna be negative 1 half log 1 minus xy. This is, I'm happy to give it, I'm so happy that this worked out, that I don't care what happens. And I'm gonna make this look even prettier, too. Please tell me we don't have to solve for y in this one.
No, just the constant.
Oh my God, okay, that's like another lifetime of math that we don't have. And then plus 0 equals c.
Should the second log be a plus 1 plus xy?
Yep, thank you. I appreciate you're watching that carefully. That also makes me happy. Lots of things are making me happy today. That is cool. Man, we're living on the edge. This is like climbing like El Capitan, you know, like no ropes, nothing. What's that? It's like, yeah, it's like wingsuiting. That's some shit. I'll do this and I'll never wingsuit. You've gotta be a maniac to do that. All right, what else? That was a good question, Lavina. A really good question. So.
So for this one, I feel like mine is like
Did you get it?
Yeah, and so you only add 1 C. Okay, so like when this comes out like this, just tack it on the right. So, so then, yes, but then you have to put in your, you don't have your initial, okay, cool. So now you have to solve for y. So this equation, yeah, just solve this for y, it shouldn't be too bad. Yeah, but that looks good. How you doing? We're still working on this guy here. This is a different one. No, this is, okay.
I was trying to double check this, because I'm not entirely sure.
Oh, no, you're fine. You're fine, Nathan. You know, very polite, kind gentleman. All right, so, let's see what we got here. So, oh, that's right. Okay, so here we are. Okay, got it. So you started is this, and you integrated with respect to x, that looks.
I wasn't sure about that last
So
one.
that's not, so you still have a 10 in front of it, right? So that 10 stays there, and then the 1 half multiplies by the it's 5. So now you see when you check the derivative, you get the 2 comes out in front, you get 10x. And then that looks great. And then add on plus c of y. Yeah, now differentiate that with respect to y.
And then that should be good.
question, and I don't think I ever made it back over here.
Well, Nathan
Sorry.
helped me, but I'm still a
Okay.
little bit unsure. So
Like put in,
It's like
once I get
you use the wrong
this.
formula, you get the right answer, but it's like, no, that way.
I'm just confused about how to get it into the Y form.
Okay, well, show me where you're at.
So I have C prime.
That seems right.
So
You also get
Oh,
one
wait, you
wrong
have
on
C
that.
prime, but you don't have C. Okay.
I also was doing it in the dark at one point.
So
I
where's
was
C?
like, I did it right from
the derivative of this.
And where's the F thing? Where is your like first stab at F? Is this it here?
This is here.
Oh, okay, got it.
Cool, I'll
Okay.
just click it.
So integrate that, and that'll be C.
Sorry.
Okay. So
Just sitting there, I was like,
version.
I should go to bed.
Well, you're gonna get better at it, my friend.
Minus
There's a times
Mhm.
two.
that's just minus.
There you go.
Seriously. I'm like,
But
it's
still.
not
Yes.
So let's write out. Let's write out real nice and clean. So F equals
That's cool. I didn't
this.
know they had TDs for those.
I don't really understand this one.
Yeah.
Plus C of X.
Because also I think it's
9x
Oh, interesting.
squared
Oh.
2x.
Okay, great. And so our answer is this equals C, right? So we're gonna have this xy cubed minus 9x squared minus 2x equals some constant. And we don't have to solve for it, so that's cool. We have to solve this for y. So what if I gave you this? Is it okay if I write over here really quick? What if I said to you, hey, I've got, how would you solve for y?
Algebraically, we
There
just
you
have
go.
to solve
Yes.
the y. Okay.
So that's the same.
I just didn't know where we were supposed to pull the equation from to get the y.
Gotcha.
And I get F.
Yes.
Okay, thank you.
You're welcome.
Yeah, I'll be right there, I'll be right there, it's all good.
No worries, this is beyond different.
Question why this is wrong. This one wrong.
It's greater than that.
Where's this one here? So you should be taking, yeah, okay, oh, I see. Got it. Oh, you're checked, that's your check, okay, got it. Oh, very good. That. I agree. So then partial so it's just constant, awesome, cool. Chemistry living zero. Maybe did you try simplifying it, or, I don't know why that would matter. Cause boy, that looks. Yeah, I did try to simplify, could use it at 5x minus 6. Let's try it and see, but I don't see why that would matter. Oh, plus C over X. Cause the C is over X, so. Right, and that should be X over X. Yeah, you were gonna do that, just, let's try it. So it knew that. What the hell?
Yeah.
I don't understand.
Oh,
Let's
yeah,
look
you
and
have
just
to
make
put
sure all
C
the
just in
deets
there.
are right here, so y
C
cubed
becomes a variable.
minus
Isn't that dumb?
9x plus 3x.
That's not right, but okay. So you don't actually have to solve for C.
You still have to set it up like you're going to solve for C, but then you put it in terms of Y. So it's like Y in terms of C. I just said it.
Yeah, I get it, okay.
Alright.
It's probably, you can probably
Yeah.
chase it through and
I
it might
should.
fix it, yeah, that's the problem,
Got it.
that's your problem. Wait, somebody, oh, yes, Chris, hi.
I know. I'm struggling a little bit.
Okay.
Okay. I'm very confused. Second step.
So, okay, so we got this, so that's your M. Your M is very newish.
Yeah, I know, yeah.
Yeah,
It's probably.
it's okay, yeah, I think it probably is. So, you didn't tack on your C when you integrate. Oh, wait, no, you seriously, okay.
On this
This is
matrix,
the check,
on this
okay,
matrix, yeah.
got it.
What was that check?
So what's going on here?
Yeah, that's right. This is. Then I have to. Don't I integrate this in step 2?
Yes, with respect to X.
And then I differentiate with respect to Y.
Yeah, but don't forget that you tack on. So you integrate this with respect to X plus the CY,
Yeah.
and differentiate with respect to Y.
Okay.
That's what's
Yeah.
up. You just got a little
Yeah.
lost in there. Yes.
Did you put that sine and theta on there?
No, but that's cool. I wish I had.
Okay.
There's something in one of these rooms I hid long ago, like over a decade ago. I don't even freaking remember. It's somewhere in one of these little holes in the wall. I don't know what it was. I don't remember what it was. I
It's
don't
the
know what
answer
it
to
is.
the final.
That was funny.
He knew he was only given 10 years.
Oh, yeah.
Now
Yeah,
I want
if
to
only I could think more than 2 days ahead at a time.
in the ceiling tiles, honestly.
Oh, yeah.
What's that?
There's a lot of space up there. In my high school, we had this kind of ceiling tiles, and one day all of our like chairs were in them. So we walked into the classroom, and all the chairs were
Really?
in the ceiling. It was an interesting time getting them all down.
We used to have at, when I went to the University of Illinois, they had these steam tunnels that we could never get into that went under the whole campus.
We have those here. We have
Do?
tunnels under campus
What?
here.
Yeah,
Yeah.
and it's like, doesn't it go from like main hall to like
Yeah.
here actually?
It goes to main
It goes
to
to
Carroll,
Carroll.
to the library, and there's one to like O'Connell, I think.
I want to go
gotta
in
get
there
in.
so
That's
badly.
Yeah.
I'm going over.
You can get in through
I'm trying to
Carroll,
build towers.
you can get in through Carroll, you can get in through the basement of Maple Hall.
The nuns used
But
to walk on the
the
path.
basement of Maple
I'll
Hall
be honest
is
with
really
you,
cool.
so
The boiler room has asbestos in it.
Yeah, that
So-
is right.
Oh, then that would do it, yeah, yeah.
Yeah, so then with that and then
I turned away from it
here,
and I
I
drove
self
over.
the studio. I
It's
got
fine.
the
Oh, okay, okay.
And then so I plug it into the quadratic formula, the y squared is equal to 6 plus or minus 30.
But so, Labita, did you get this one to work out, the crazy one that you came by to see me about? Did you actually get webwork to accept it?
Yeah.
Okay, it can be done. Okay, that's,
Okay.
we need to know that.
Michigan number 2.
Thank you, Brett.
Sorry.
And then I kind of like just multiply,
I did get it.
these two ones and just multiply by this way.
You should have something like.
And you double checked all
That
this
looks right.
stuff.
Is it plus or minus? Feels weird.
I think it
that
was
it's
Just these
plus.
multiplications.